Good morning, everyone. I am Andrew Robichaud. I'm level one support here at New Era. We'll be getting started here with our Valboot webcast. You'll be basically going over everything that's currently included with your maintenance downloads at no additional charge. Um, if for whatever reason at the end of this webcast you want any more in-depth training for yourself or team, please contact us at support@newera.com. Otherwise, Paul, go ahead and take it away when you're ready.
Okay, thank you, Andrew, and welcome, my friends. We're here today to talk about validated boot and the creation of all of its structures, key rings, certificates, profiles, and permits to those profiles. We'll be together for about 35 to 45 minutes, but I thought it might be more appropriate to begin this by just going straight to the end game. Because what we're really trying to do here is to set up an environment where we can create what's referred to as a secure boot. Now, a secure boot's been around for some time. It's popular on Linux and Unix and Windows. And essentially, what its objective is to make sure that no malfeasance has taken place along the supply chain in the creation of the operating system. And the way in which that's basically done is that the components of the operating system are signed, and the actual signing components are passed forward during system initialization or a secure boot. And the operating system itself uses a public key to determine whether or not those components in some way have been modified. And if they have, of course, that would identify the fact that something happened to that component while it was in the supply chain on its way to that particular machine. So it's not a particularly new thing. It's been around for a while, but we haven't seen it on z/OS. Hold on just a minute, because in the case of z/OS, even though our supply chain is similar, there is a gap where from the time in which we receive the operating system from IBM, after it's been through its various stages of components from Germany and Britain and India and the United States, assembled together and then distributed to you through ShopZ, you take it and test those components, whether they come from IBM or from an ISV, using the code scanner or image focus, hopefully image focus. You check all the boxes, make sure everything is appropriate for your organization, and then you pass it on to be installed on any number of KEX, in this case 3. So what happens is that the result of the fact that you are now injected in the supply chain itself, this sort of breaks down the secure boot process, because the malfeasance is concerning whether or not someone in the process of customizing that operating system might have entered some nefarious code, or while their back was turned, somebody else entered some nefarious code. And so there's no way, or has been no way up until this point, for z/OS itself to determine whether or not the components that it's using in initialization actually can be referred to as a secure boot. So in order to sort of fill that gap, what is being recommended is that we create a clean room environment. And in that clean room environment, we extend that supply chain to include validation within it before we move it on to a state of initialization in the various KEX that we have. So when we look at that process in detail, on the left-hand side, we see that clean room environment. And on the right-hand side, we see that initialization process itself. In the clean room environment, we are going to continue with the validated boot processes themselves. That is the continuation of that supply chain. But in order to do that, we have to create key rings and certificates. We have to create various profiles in our data lab and facilities class and CSF keys class. And we have to, in essence, authorize individuals, a small group of individuals, maybe just one or two, to actually become the signers of the components that we are going to pass on for initialization in a new form of IPL called a list-directed IPL or an LD-IPL. And in doing so, we not only pass the components forward, but we also have to pass the certificate that was used in the signing so that its public key can be embedded in the HMC so that when it passes on that information to the various LPARs, when those LPARs are IPL'd, that public key can be used to validate that those components, in fact, came from a trusted source, you. And so this is our job now. This is a sort of a hole in the security processes themselves that revolve around the z/OS environment. Everything's been cool all the way through the validation up to the point where we received it and then we checked the boxes and modified it. That validation string was broken at that point in time. Now this is an opportunity for us to put it back together again so that we can, in fact, have a secure boot of the z/OS operating system. Now, we can do the boot either in an audit mode where we would get a warning that one of the modules is now not signed, and we could then go examine that and try to figure out what happened. Or we could do it in enforce mode, which would mean that we would enter a wait state and everything would stop until we fixed the problem and then reattempted the IPL itself. There are lots of individual bits and pieces of documentation that I believe are worthwhile your attention. The first one, which is from the National Information Assurance Partnership, sort of gives the background generally on secure boot, why it's important, what it means to us in terms of the integrity of our operating system environments, and gives some examples of situations that have occurred in the past that indicate the tragic nature of infecting the operating system with some sort of malfeasance. Probably the most tragic one of all was SolarWinds back in 2020, and you all probably recall that. But there's current rumblings now, even about GitHub having problems with infiltration of certain of its components that are not able to be appropriately verified when they finally reach their endpoints. And so there's some links here. They're worthwhile tracking down for background information. The real seminal report here and the seminal work is from Kevin McKenzie, who is the Validated Boot System Architect. And I clearly recommend that document for a better understanding of all the details that revolve around validated boot. Document is 35 pages long, but it's definitely worth the read from A to Z. It will cover the entire picture. There's more detail about the profiles that are associated with the validated boot structures, and particularly the last one here, the IRR program V2 signing, is the defined name of a facilities class profile that must be used in order to kick off the process of actually authorizing the signing of the resources with the components that we are going to build. The tool that we're going to use today is called ValBoot. And ValBoot is a part of the Image Focus Security Supplemental Applications. So as Andrew mentioned, if you are a licensed user of the supplemental inspectors, then this will come along as part of your next maintenance upgrade, okay? If you're not, work with technical support and they'll be happy to get you the appropriate licensing so that you can actually give this a whirl. It executes either directly under TSO-ISPF, which we're going to use today, or it can be executed in the VTAM environment, which gives you access to the ICE primary menu. So either one of those will work appropriately. The goal, of course, is to build the infrastructure itself. And you can see that in the upper part of this diagram with a couple of examples of certificates and RDataLib and facility class profile content being displayed in 3270 screens. Even at that point, that is, once we've built all that structure, the question is will it work? And the only way to truly verify that any of this works is to exercise it against IEW Sign, that program that will be actually used for signing the modules in a specific library. And so we're going to do both of those. We're going to not only build the infrastructure, but we're actually going to sign modules themselves. The signing process is somewhat complicated, but it calls into play all the members and pieces of the structure itself. The first thing that it's going to do is it's going to call a program called RPMG Signer Ver. And that callable service is then in turn going to make a decision as to which of the facility class profiles best fits the user who is attempting to use the IEW Sign program itself. And there are a number of different ways in which that profile can be created. And you can see those highlighted in yellow here. It could be that it was a combination of a group name and a username, which would in essence mean that that user has to be a member of that group. Or it could just be an extension with the username. That's our preferred method and the one that we will use today. Or it could be a more general profile that doesn't have a username associated with it at all. The key point about that facilities class profile is that within it, it contains an APPL data component that defines the keyring and the owner of the keyring that's going to be used in the attempted signing itself. So we not only have to have access to the facilities class profile itself, we're going to have access to that keyring. And in order to get that access, we're going to have to be permitted by our RDataLib profile. If in fact all of that works according to the way in which we hope it will, then the the keyring will contain a signing certificate, and that signing certificate will actually be the one that will be used to sign the resources themselves. But its private public key pair will have been stored in the PKDS, which then means that we also are going to have the appropriate permits to the CSF keys class in order to be able to use that particular certificate for signing. So there's a number of different steps here. All the way along the way, there's typically a profile and some permit, another profile and a permit, another profile and a permit that's necessary in order to complete the process of signing in the, in the clean room with the private key, and then send those resources over to the appropriate CAC, where we'll also have to have transferred the public key, as you can see up at the very top, and those two get matched up, and hopefully we'll have the necessary resources and permissions to have a secure boot. Now, today we're going to use a demo case, and what we're going to do is we're going to be aiming to try to create signing infrastructure for 3 different groups. We have 3 different techs, so we'll try to get that accomplished. Our goal is to set up all the key rings and certificates and profiles and permits. If we do that correctly, then the users will be able to sign resources. They'll be able to evaluate their findings. They'll be able to identify the documents that were actually used in the actual signing and export them to the appropriate points in the process itself, export the certificates, and then record the signings optionally in the ICE control journal in order to keep a permanent record not only of the signings, but also the export of the certificates themselves to other locations. Within ValBoot, there are 3 different role levels. You can be an administrator, you can be an authorized user, or you could be an auditor. And all of these are permitted by specific named facility class profiles. If you are an administrator, you will also need to be RACF special. That's required because of all of the work that goes on to create profiles and permit individual users to them. Authorized users don't need to have special authority, nor do auditors have to have special authority. The profiles themselves give us the information we need to limit access to functionality within the application. So I'm going to go ahead and end this show. We'll come back later on to wrap up. But let me go to my 3270 session. Okay, so here we are. Now this is just TSO ISPF, so I'm going to go to the command line, TSO $ command line interface, CLI, comma, asterisk, ValBoot, VB, and I'm an administrator. So that's it. So now what we're doing is we're going out and checking to see if there are any certificates in the environment that match the naming conventions that are used within the ValBoot application itself. And you can see those conventions here on the panel. Validated boot.ca, validated boot.sg. We use 2 certificates. You can do this with 1, but we recommend 2, where we have a CA certificate, that is the certificate that will be used to sign the signing certificate itself. We have a prescribed defined certificate naming convention. This allows us to scan the RACF data store very quickly to pull out all of the validated boot components. We do the same thing with key rings. We do the same thing with profiles. It's really critically important because it's not, as I mentioned earlier, it's not just a matter of setting this up. It's a matter of managing it over time so that we can set it up today, but what happens a year from now? What happens with one of these certificates gets near expiration? What happens when there's turnover in the organization and we have to permit new individuals? To eliminate the guesswork, we're prescribing what the naming conventions of the key ring, the certificates, and the profiles themselves need to be in order to be able to manage them appropriately over time. You'll notice here that on this panel, it says right off the bat, there is a warning in our certificates. If we click on ValBoot certificates, it'll tell us what it's warning us about. There is one of our signing certificates, this one right here, which is owned by me, which, by the way, is attached to a key ring. It is an elliptical curve component. It's stored in the PKDS and it will expire in 26 days. And so there may be some action we want to take in order to correct that. We could at this moment, if we chose to, simply decide that we want to renew it. And in this case, it would renew it out for a specific year. I won't do that now, but just to know, if we get a warning, there are actions we can take directly from the panel in order to fix them. Now, if we go back and now we click on key rings, we can see all the key rings that are there. And this is a sort of nested display. Not only does it show us the name of the key ring, but it shows us the name of all the certificates that are attached to it. And of course, here's the one that we were just looking at. We know that there's a warning in this key ring. The warning could be that there's no default. The warning could be that there is a certificate that's not trusted. The warning could be any number of things that could impact the integrity of the keyring itself that would make it not functional. If I go back, we click on the upper right-hand corner to VB management, we'll see a more conventional presentation of options. The key rings at the top, which we've already taken a look at, a drill down directly into the RDataLib profiles that are used to protect validated boot. The same thing's true of the facilities class. Not only doing that, but also letting us know the key ring that is defined in that APPL data segment within that specific profile. So a lot of good information here to be revealed. Certificates again, certificates that might have been exported, renewed, PKDS, TKDS information about their profiles. As I mentioned earlier, it's one thing to put all this stuff together. It's another thing to know whether it works or not. And we can check that in two specific ways. One, virtually, without running IEWSign, to determine whether or not a specific individual, in this case, my user ID, has access to any of these profiles. In this case, I don't, because I do not have access to this particular APPL data component, this keyring in the RDataLib class. So I would be denied access if I attempted to use this. If I go down one, and in this case, I can actually use this particular profile because I have alter access all the way through this. And it goes on and on and on for each of the individual key rings that would be defined using the convention associated with the facility class profiles themselves. Again, remember the convention defined by IBM is IRR program v2 signing. Any of those, we can evaluate them, determine whether or not a user has access to it. And the important part about that is that now if we actually come and test it, we can actually see whether or not that particular profile will be discovered by IEWSign when it says, hey, which profile is out there that matches this naming convention that this person might be able to use to sign certificates. And in this case, it will take a look, find the one that's appropriate. In this case, what we're doing is we're showing you interactively what the JCL looks like for actually running IEWSign. Now, if you were a user or you were an auditor, you wouldn't see that because that's not appropriate in our opinion. And we have a real-time version of running IEWSign that hides this or masks it from the users themselves. But if you were curious about this, you could highlight this, drop it into a member in a data set, submit it, and it would work equally well. A PF3, it asks me if I want to continue. I say yes. Of course, the more members that are in a data set, the longer it takes. This is what the results look like. Everything's successful. PF3 back, PF3 back, PF3 back. Now we're back to our original menu. If I look at the data set itself, just put the cursor under the library itself, now I can see all of its members. If I look at the members, you can see that's typically what you would expect to see. But if I now go back and go to the right, and this is the data set that I put the signed members into. And now I take a look. And I can see these 4 extra lines have been added at the bottom. And every module, every object that gets signed in a library has those 4 lines on the bottom of it that contain information, I suspect, about the certificate and the algorithm and et cetera, that gives the operating system the opportunity to say, hey, does this match up with what is expected from the signing information that is shown here in this last 4 lines? And if it does, then I consider this module to be good, qualified, validated, and I'm going to use it. If it doesn't, I'm either going to print an audit message or I'm going to go into a wait state. Totally up to me to make that decision. Okay. All right. So let me back up. Let's just give you a quick rundown of what we've got here. And also, by the way, if you do hook up the control journal, all your history is here of everything that's been done. Okay. So signings, exports, everything, complete audit log of all those activities. All right. So the first thing we're going to do is we're going to delete some stuff here and get down to nothing. So we'll at first delete some key rings. Now, we all know that if we delete a key ring, it will obviously delete it for us. There's always a trace behind all of the actions that are taken across our entire offering. So in this case, both for ValBoot and CI 3270, you would find this kind of a trace information. So that key ring's now gone. Let's get rid of this one. So we're deleting the key ring, but we're not deleting the certificates because they still remain. If we were deleting the certificate would be deleted, but RackF would automatically delete it from the key ring itself. So we'll delete this last one. So you can get an idea of how interactive and relatively straightforward this is. So no key ring records remain. Now we're going to go delete some certificates. So that's 1. That's 2. That's 3. That's 4. Okay, so no certificates remain now. And by the way, when you log on for the first time, it's quite likely, very possible that that's the message you will see. And just hit enter and you'll come into the primary menu and you'll be in the current state that I'm in right now. So the first thing we want to do is we want to create a key ring. So I'm going to create one for my friend Jim Lautner. So he's JLaut1. I also want him to be the owner of the key ring. So I'm going to go ahead and check high-level qualifier ID. I'm going to come down here and I'm going to click on create, update, profile a ring. And here is what we get. So behind the covers, what's happened is that we've created the command structure that's necessary to build that key ring for Jim, make him the owner, create the facilities class profile that's associated with it, the RDataLib class profile that's related to it, and can permit here additional users. So I'll go ahead and permit myself. Oops. B-row B1. To do as many people as we want here. Might as well do one more for the fun of it. We all know Pat, so we'll permit Pat, because if we didn't, Pat would cry. Well, not really, but he might. By default, they're given read, but we could type in control, we could type in alter, we could type in whatever we deem to be appropriate. If we're satisfied with what we see, particularly this is important to realize that inside of this facility class profile, we're going to have an APPL data component that's going to recognize a SHA-512 signing algorithm against a against a keyring that's owned by Jim that has the name of validated boot signing keyring, Jim Lautner 1. So I'll go ahead and press enter. So once again, a trace behind what we did so that we can follow along with everything that's happened. So the first thing we did was we issued a RACD cert to actually create the ring. We didn't get any reply back. Everything seems good. The next thing we did was we created an RDataLib profile with a UACC of none. Will not be reflected until we do a refresh. We permitted Jim to it, and we permitted, that's interesting. That should have been me there. We created a facilities class profile. And we permitted myself and Pat Harlow to it. And then we refreshed everything. So now when we PF3, we now see our keyring. So it's owned by Jim. This is the name of it. It has an RDataLib and a facilities class, and it has no certificates attached to it at this moment. We could look at the RDataLib profile. Okay, so in addition to Jim, me, and Pat, we can go back, we can look at the facilities class. Yeah, 3. Now, if we wanted to, we could actually come back here and do this. And resubmit it. Now, the only thing that's going to happen is we're going to start to get messages out that would normally be shown on the screen that indicate that the profile actually already existed, okay, and that we can't add it again. So we don't suppress those kinds of messages, whether they come from RACF or whether they come from ICSF, because we find them to be particularly important in understanding the bigger picture of the status of things at the time in which we issue our command. So it's a good thing. And now we're back. So now let's PF3 back. Now we have a keyring. Let's build some certificates. Now remember, our certificate names are prescribed. One has an extension of CA, meaning it's the signing certificate, and the certificate authority. Another one has a extension of SG, which means it's the signing certificate. We think that you should assign the tech name as a suffix. So in this case, CEC002, that's the one I use for Jim. These have to be the same. The tech names have to be the same. And the reason for that is because we're going to sign the signing certificate with the CA certificate. At the time that we were to renew this signing certificate, we need to know without fail what was the CA certificate that was used to sign it. And this is one way in which we can do it. Common name, we might call it Jim. We might call org name. Now, the number of years to expiration for a CA certificate by default is 5. You could set it to 1 or 2 or whatever you like. The number of years for expiration of a signing certificate is 1 year, but you could set it to 2. Just depends on how you want to do it. So now we're ready to go. We've got everything that we need in order for our certificates to be built. And so here we are. We now have our key ring up at the top. This is what we're going to attach the certificates to. We have all of the ins and outs, if you would, of the commands that are necessary to build the CA certificate. Notice the CA certificate is going to be an RSA 4096 size, and it's going to have a PKDS label associated with it, which means that the private public key pair is going to be stored in the PKDS. So it's going to be CSF keys class profiles that are going to be associated with that, and we're going to have to be able to permit individuals to it. Notice that the certificate that will be used for signing is actually being signed with the CA certificate itself. And so in addition to that, this is going to be a NIST ECC key. It will be stored in the PKDS as well, and it will be a size of 512. And we'll go ahead and generate that. Now, because it's a 4096 size RSA key, it'll take just a few seconds or so in order to do the mathematics and compile the keys themselves. In CI 3270, all of these values like key size and type and everything are ad hoc. You can change them to whatever you want. In ValBoot, they are specific to the validated boot structural process as defined in Kevin McKenzie's report. So here's our trace again. All the components. We refreshed everything. We're essentially good to go. Let's have a look. So now when we look at our key ring, remember last time we looked at it, it didn't have any certificates attached to it. Now it does have those certificates attached to it. If we were to list the ring details, it looks like this. Here are the two certificates that we are looking at. We could export these certificates now. Remember, the signing certificate will need to be exported out in order for it to be used by the HMC. So now we can say, okay, well, let's export that thing. So we say, all right, let's do that. And when we do, this is the typical view that you would get of an export data set. The data set is created automatically by the system itself with a prompt of this, but with the automatic attachment of my user ID by RACF or by RACD-cert. Now, this is interesting, but when I hit PF3 and go on to the next screen, this one becomes a bit more useful. This is the one I think you would probably want to send to your friends at the Keck, because what it has is all the detail that's associated with that certificate. For example, its keyring, excuse me, its fingerprint, that's going to have to be entered in the HMC to validate the certificate itself. It gives all the commands that were used to actually export it. And then it actually gives us the certificate again. Oops. Sorry. All right. Here's a certificate. Decodes the certificate. Tells us what keyring it's attached to. All the information that can possibly be available about that certificate is made available in this screen. So this might be an adjunct to sending the export file, but you can also send this one if you chose to do it. If we PF3, then the next thing that pops up is a question. Do you want to post a summary of this export to the control journal? If you're keeping track of your work, if you want to have an audit trail of your work, this is the ideal opportunity for you to say, yes, I would like to go ahead and do that. If I hit enter and I say yes, then when I come back, I can see what the summary looks like. It gives me all the pertinent information, the library it came from, the target it went into, who did it, what was the certificate that signed it, what was the export data set that was used, what were the characteristics of the certificate itself. Did it have a private key? Yes. If it didn't, you're dead. Is it trusted? Yes, it is. When does it expire? What was the algorithm used? And what was, importantly, what was the fingerprint that was used? Because if there was a discussion between you and the operator of the HMC about a specific certificate, then it's quite likely that this fingerprint will become a relevant piece of information. There are other ways to identify certificates, but the absolute gold standard is to identify it by its fingerprint. PF3 out. Okay. All right now. Oh, sorry, it went too far. Again, from the GSO command line. So I think you pretty much get the idea that that we can create these things. Let's see if Jim can sign. Okay, well, according to this, my buddy Jim should be able to go ahead and sign. That is, we have set up everything that's necessary for him to do it. And I stress that if you may have done this before, but certificates can be frustrating. Profiles and permits can be frustrating. And setting it up and then running IEW sign and not getting the result that you're looking for and not having a clue as to where to go, at least in ValBoot, it's going to tell you exactly what's going on. You're not permitted to that. It doesn't exist. You don't have the appropriate authority, blah, blah, blah. But it looks like Jim should be able to sign. So we're going to back up. Now, remember, I'm logged on as PRoby1. So I'm going to be signing for Jim, or signing as Jim, I should say. So if we look up here, we can say the acting signer is this, but the session owner is that. Let's see what happens when we say, can we sign? So, all right, confirming JLOT1 signing of sys1.svclib. Okay, press enter. You can see the username here in the JCL is Jim. You can see that the report itself is going to go to PRoby1. So it's going into a data set that's owned by me. Press PF3, continue. So now we can see success. So I'm running out of time here, so I'm not going to do it for the other two texts right now, but I think you pretty much get the idea. If I'm the administrator, then I can set up the signing infrastructure for any user, and then set up our facilities class profile to give that user access to the signing functions that allow them to be able to go forward and sign components as they see fit. So typically what would happen is those signers would see this panel. This would be as far as they would get. They would say, I want to do some signing. We'd say, fine, here's your panel. Put your libraries here, do your signing. Everything will be cool. This panel is specific to a user. So whatever libraries they enter here would remain in here. Notice that we are tracking the nature of the libraries themselves. Are they PDSs and do they have undefined formats? Yes, they do, except for this one, which has a fixed format. And if I try to have Jim sign that, then it'll come back and it says the source library has a record format of FB. I mean, this is no good. You can't sign that. You can only sign the ones that have load modules or objects in them. This won't work, okay? And over time, what happens is that these build up, okay, for the user. So the next time this user comes in and launches this panel, he's not only going to see the source libraries that are associated with his collection of libraries that he wants to sign, but he'll also see the collection of actual signed libraries. So that if for some reason he needed to export one of these to the CAC again, then go for it. That essentially could be done. Okay. All right. So I'm gonna just go back here real quick and wrap this up. So my hope is that by now I've pretty much convinced you that we can build it. We can build the structures. We can use them to sign things, no question about it. We can report on the signings. We can export the signed certificates, and you can pack-to-pack copy the actual signed resources. And we can post information for an audit trail for you directly to the control journal. Later on, early next month, not April, but May, we're going to come back to you with another application called CI 3270. And what CI 3270 does is it provides a gestalt, a complete audit of RACF and ICSF as it pertains to certificates and key rings and RDataLib class profiles and other profiles that protect PKDS and TKDS components. We'll be able to generate and add certificates. We'll be able to make signing requests. We'll be able to build and connect certificates. And I should add, not only generate single SAN, but multi-SAN certificates themselves. Okay, so that's it for us. If you want to see more about New Era, you can click on this YouTube logo here. This will take you to our YouTube page. But if you would also like more information or have any questions, just simply email Andrew and he'll be happy to do that. Okay, thank you, my friends, for coming out. I want to say one last thing. My good friend Barry Schrager signed up for this webcast, and I'm really pleased about that. For those that you don't know, Barry is credited with being the father of modern mainframe security, being the original author of ACF2. Thanks for coming out, all of you, and especially for you, Barry. Okay, Andrew, I'm back to you.
Okay. If anyone has any questions for Paul, now would be the time to raise your hands. It's at the bottom of the Zoom screen. I will unmute you if you do have a question. Otherwise, this is the end of the webcast, and I'll give you guys about a minute or two here to commit to the hand raising. Okay, looks like we don't have any questions, so this will be the end of the webcast. Everyone, thank you, please, or thank you for coming out. We'd love to see you out on another one. All right. Goodbye, everyone.